Sing by Speaking is a novel singing voice synthesis system that can convert a speaking voice reading the lyrics of a song to a singing voice. By using this system, anyone can synthesize and listen to their own singing voice by not singing a song but only reading the lyrics of a song. I had been interested in the question, what is a natural and human-like singing voice? To examine this question, I have investigated the acoustic features affecting singing voice perception and then developed a singing voice synthesis system.
立ち止まるとき、またふと振り返る。立ち止まるとき、またふと振り返る。立ち止まるとき、またふと振り返る。
Sing by Speaking converts speaking voices to singing voices by adding several acoustic features, such as overshoot, vibrato, and singer's format that are unique to singing voice. The subject of my research is to understand the singing voice by synthesizing the singing voice. In other words, I try to understand the mechanism of human singing voice production and perception by synthesizing natural and human-like singing voices. Toward music robots that understand music, we are engaged in developing a robot that understands music. The objectives of our study are twofold. First, we want to know how robots understand music by constructing such a robot and evaluating its performance. In other words, we adopt a constructive approach towards music understanding robots. Since time delay exists in music processing systems inevitably, the key technology is prediction and correction in the design and implementation of a music robot. Second, we want to know how people understand music based on our experience and observation with music understanding robots. We will extensively evaluate a robot's behaviors in various situations to confirm that a robot really understands music and behaves accordingly. Effective information is important for intuitive recognition by users and is potentially available for use in the design of sound editor, music player, and information retrieval systems. M-Cube is a mood visualization system for music using various colors in real time. We have assumed that the chordal structure of music is the factor determining musical mood, based on what we calculate the mood scores and map them to color space. M-Cube was implemented to calculate mood scores based on chord perception model that uses solely the acoustical features of the pitch combinations for calculations of the total tension and mode like major-minor of chords. Major chords are rendered in magenta line, minors are in cyan, tension chords are in yellow line or other murky colors. M-Cube cannot only deal with MIDI signals, but can also be used with acoustical signals such as CDs or microphone input. M-Cube visualizes the traits using various colors that are directly linked to music moods. They are based on perception model of dissonance, tension, and mode like major-minor. Future work will extend to system to extract musical moods from temporal sequences such as cadences and chord progressions. What is the difference between hearing music and listening to music? Our research focuses on the differences in brain activity caused by various modes of music perception. Many well-trained musicians often claim that they can change the mode of listening to music depending on the situation. The purpose of our research is to measure the empirical variances in brain activities. We carried out an experiment to measure the activity of the prefrontal cortex when musicians listened to music actively or passively. The stimuli used were 6 classical works for piano and 6 sound sequences based on the classical works, which were divided into fragments and randomly ordered. We measured the brain activation using near-infrared spectroscopy technique, while musicians listened to the piano works or shuffled sound sequences actively or passively. As a result, it was observed that the active listening to the original music, which meant trying to understand the musical structure, activated especially the ventrolateral part of prefrontal cortex in the left hemisphere. On the other hand, the dorsal part of prefrontal cortex was deactivated. In the future, we hope to further discover the brain mechanisms to process sound sequences as music perception experiments. Expert pianists can maintain a virtuosic musical performance for hours without muscle fatigue. What is the motor control mechanism underlying such a motor skill? The goal of this study is to elucidate the efficient piano technique quantitatively. The motivation is based on my past experience of having tendonitis during practicing the piano. To this aim, I developed equations of motion to quantify all forces acting on the upper extremity during a piano keystroke. By comparing the motions used by expert and novice piano players, I successfully determined that the expert pianists exploited greater amount of non-muscular force for striking the key compared to the novice piano players. In particular, the expert pianists effectively produced motion-dependent interaction torques during arm downswing and thereby reducing the muscular strain. I'd like to offer these findings on the expertise of expert pianists to piano players and educators. My ultimate goal is to create a world where everyone can realize the desired musical expression in piano performances without suffering from any physical injuries. It is desirable in the field of animation and music education to develop a technique for piano performance animation using computer graphics. However, previous techniques for computer animation of piano performance have been mechanical and tended to lack musical expressions. The study of Professor Nakada and her colleagues is to develop techniques to reproduce the playing of instruments with very delicate and fine motion by using detailed and natural-looking computer graphics. Here, we first obtained an accurate data of playing piano by using a motion capture technique. Then, based on the obtained data, we produced animations by CG. You can see that it is successful in expressing delicate motions. Currently, we are trying to generate the motion of the fingers from a musical score. Also, we are developing a music interface for controlling the tempo of music in real time. In the near future, we would like to produce a pianist character playing a piano with full of musical expressions in the virtual space.